No questions? Very, very good. Now I'm going to go to the class, the actual lesson, and I want you guys to take a look, okay? Take a look at task number 1. So before we go to today's lesson, which is the age problems, I want to review the numbers and the 4 operations with you. And I hope that you didn't forget your number places, your place values, and some of, these vertical formulas or long formulas, as your teachers would call them. Okay, why don't everybody take a couple of minutes, and then I'm going to ask some of you. Time starts now. I'm gonna ask a couple of you to answer these questions, okay, as we go through them. Okay, time is up. Who wants to do the first one? Express. Okay, Kevin. Okay, Kevin, go ahead.
It's 9,523 in words. It's supposed to write 9,520.
23.
Actually,
I'm gonna, you know what? I'm gonna erase these because I want them to be in letters. Okay, so we're gonna do 9. Oh, this guy come. 9,523. So this is how you express a number in words. And the second question, who wants to do it? Felix, can you do it?
It's in the tens place.
Oh, very good. Thank you. Yes. So let's go over this whole thing. So Felix told us 2 is in the tens place. What about 5, guys? Hundreds place. What about 3? Ones. Okay, this is ones, tens, hundreds. Okay, I'm not gonna write everything. Yeah, because it's gonna be, oh, oops, did I misspell? This is not gonna be tenth. It's actually S, not TH, okay? Tens place. Why is this guy always there? Thousands. Very good. So third question. What does the digit 5 represent? 5 represents what? Is it 50? Is it 5? Is it 5,000? Let's find someone who has not. Tony?
500.
Very good. 5 represent
500.
500. Okay. Now next question. How many thousands are there in this number? How many thousands are there? Let's find someone who has not answered any questions. Irene? Hello, Irene. Can you answer this question? How many thousands are there?
9.
9. Very good. Thank you. Now, the last question. about this number. Express this number in the expanded form. What is the expanded form? Anybody knows that?
I know. It's like
writing an equation.
Yeah, it's like, for example, if you have 838, in the expanded form, it's 800 plus 30 plus 6.
Very good. Very good, Kevin. Thank you for that. So I'm going to start with writing down this number. I'm going to say equals, sign equals. And who was raising hand? Was it Tony? Tony, can you give us what this, on the right side of it?
500 plus 20 plus 3.
Okay, very good. Oh, I'm so proud of you guys. So yeah, so that's your level should be, right? So when we are entering Math Contest 1, we need to know numbers up to the thousands place, okay? And we need to know how to express them in words. We need to know each place value and what they represent. We also need to be able to write the number in the expanded form. So you have done all of that. That's great. Now, whoops, what did I do? I dropped my mouse. Okay, here. So now, are you guys ready to look at some for operations? So, by the way, these are called the long formula or the vertical formula. And this is really just, like this one would be just that, right? 96 divided by 8. It's the same thing, okay? So do you guys need a little bit more time, or do you want to just start with, we can start right now? We have some people that have not raised their hands yet. So Alan, you want to do it? Alan? You want to start with 96 divided by 8?
Is 10.
Is 10?
Yeah.
So let's do it together. 96 divided by 8. It's 12. Okay. So how many eighths is there in 9? It's just going to be 1 8 in 9, right? So on the tens place, we're going to left with 1. 9 subtracted by 8, that's 1. So copy down what's in on the ones place. 16. How many eights are there in 16? There are 2.
2.
So that would give you a clean division, right? It's a clean division, no remainders. So the answer is 12. The next one is easy, guys. 15 divided by 5. Quickly, we need someone.
3.
Oh, okay, that's good because 3 times 5 is 15. So we're just doing reverse operation here.
I practically mastered all my multiplication skills.
Okay, very good, Kevin. Thank you. So next one is subtraction. Next one, can we have Chelsea or Evelyn or Flora? You guys have been really, really quiet. Or Kaylin. Let's see who else has not answered any questions today. Irene as well. I think we have. Okay. How about Evelyn? Evelyn, can you help me with this? 65 subtracted by 7. What would the answer be for this one?
64 subtracted by 7 is 52.
52? Okay. So first of all, let's look at ones place. 5 subtracted by 7, is it enough? It's not enough. So we're going to borrow a 10 from this tens place, okay? We're going to borrow so that this 5 becomes 15. Now 15 subtracted by 7, that's 8. And don't forget, we have already borrowed 1 from the tens place. So this 6 actually now becomes 5. So copy that down. It's 58. How many of you got this one right? Very good. Very good. Now, next one is addition. 76 plus 6. Chelsea, can you do it? Yeah? 76 plus 6.
82.
82. Wow, so good. Yes, and why is that? It's because 6 plus 6, that's 12. And then we need to give that tens place a little tiny 1. right? So 7 plus 1, that's 8, 82. Very good. Now this one, you guys shouldn't even think, okay? Because this is just your 9 by 9 multiplication table. 9 plus 7. Everybody, what's the answer?
63.
63.
Very good. Very good. Now going to the next row, 78 plus 8. Who wants to do this one?
78 plus 8 is 86.
Okay, Nuolong, can you do this one?
So 78 plus 8 is 96.
96. Any different answers?
86.
86. I like 86 better. You know why? Because let's do it together. Okay, we know that 8 plus 8 is 16, and that tens place is going to be increased by 1 because this 16 is going to go up to that tens place, and we're only leaving 6 on the ones place. 7 plus 1, 86. Okay, you guys really need to work on your additions and subtractions, guys. Next one, division. Next one,
I've been
division.
practicing so much of the multiplication that I'm even getting better at multiplication. I mean, addition and subtraction.
Okay, very good, Kevin. So next one is a division problem, but it's actually very, very easy because you're just taking half of that, right? Flora, go ahead.
31.
31, very good. And how do you check yourself, Flora? You can always go back and do the reverse operation, right? You can always say, oh, did I do it right? Maybe not, right? And then you can do what? 31 times 2 equals, is it? Does it equal 62? Yes. If it is, then you got this right. So that's how you check yourself. You can always do the reverse operation. 13 times 7. This one is a little tricky. Who wants to do this one? This is a multiplication.
That's easy for me.
Hey, Nuolong, can you do it? 13 times 7.
91.
Very good. So 3 times 7. First, let's do the ones place. That's going to give you 21. But 21. Remember that 20, that's in the tens place. So write that little 2 down and then do 1 times 7. Remember this 1 is not 1 anymore. This is actually 10. So 10 times 7, that's 70. Plus this 20 that you got from the ones place. So you should have 9 on your tens place, okay? So that's how you get 91. Next one, subtraction. Who wants to do it? 43 minus 9. Kevin, go ahead.
34.
34. Okay. Do you guys want me to go over this or you're all good with it? You're all good? Yeah? Okay, I'm going to go over it because I look at some of you, you look confused. So 43 minus 9. Okay, 3 is obviously not enough to be subtracted by 9. But what we can do is that we can borrow 1 from the tens place. Now we make that 3 13. Okay, 13 minus 9, that's what? 4, right? And then tens place. You already borrowed 1 from tens place. So tens place is left with just 3, okay? The last one, guys, hey, we're moving on fast. Last one, 48 plus 9.
Any number plus 9 is usually really easy.
Okay, let's find Kaylin. Kaylin, can you do it? Alex, hey, Alex, I saw you raise your hand quite a few times. Let Alex do it. Alex, hello? Yeah, you can keep yourself, yep.
It's
okay.
like, it's 57.
48 plus 9, you said 57. Did you say 57? Yeah,
Yes,
that's absolutely
because
correct.
what number plus 9 equals, it's
17,
10
right?
Number.
Okay,
And
so
actually
8 plus
number
9 is
minus
17.
1.
Uh-huh. And then that 17, there is a tens place. We're adding 1 to the tens place. Okay, we're only writing down 7 for the ones place. So 57, very good. Hey, give you guys a round of applause. So we're done with that first task. So the first task is really just to review and warm up before we enter today's lesson, because it's actually a little hard. It's a hard concept. So
It does have a little. It does have a little multiplication and subtraction and division. So like.
Kevin, are you asking a question? What did you say? I'm
I
sorry.
just said it's also kind of like the 4 operations.
Oh, okay. Yeah. So Kevin, you're right. So although we're doing these word problems, right? If you scroll down, all of these examples, they are words. They're not in numbers. They're not equations. However, what we need to do is that we need to look beyond those words. We need to extract the numbers and equations from these word problems. So in the end, there's still a number game, right? Kevin, is that what you meant? So let's look at the 3 simple rules for the age problem. Okay, I don't want you guys to memorize this. Really, we need to understand, not memorizing. Okay, so the first rule, the difference between 2 ages does not change over time. Can someone give me an example of that rule? The difference between 2 ages does not change over time. Any examples? Let's see. Ooh. Okay, Chelsea, do you have a good example for that?
So if you're 5 and your dad is 24, and then you both add 1, and then your dad's still gonna be older than you.
Okay, yeah, that's good. That's a cute example, you and your dad. So yeah, Chelsea, thank you so much. And now I want to just, quickly talk about the second rule. 2 ages increase at the same rate over time. What does that mean? That really just means next year, if you're increasing by 1 year, your parents, they all should be increasing by 1 year. So if it's now 2021, in 2022, maybe you guys will be 9 and your parents will be 39, something like that. But your parents wouldn't suddenly jump to be 79, so we're doing it's the same speed, we're increasing or decreasing, so it's the same speed. The ratio between 2 ages changes over time, so I do need to talk about that one, and I have a good example for you guys. I want to write it down, and if you guys have your piece of paper in front of you, you can take notes now. Okay, so we're just gonna give a mom and daughter example. So if we have the mom, so now we're talking about now at this moment, the mom is 30 years old and the daughter is 1 year old. Let's find the difference between their ages. What's their age difference? How much older is this mom compared to her daughter in terms of their age? 29. Thank you so much, guys. How did you figure that one out? 30 minus 1 equals?
That's easy peasy.
Yeah, easy peasy. Thank you. 29. But what about this ratio? What does this mean? This ratio is basically, so the second rule is we're talking about the speed, right? The first is the difference. This third is basically how many times. How many times? So we're doing, okay, how many times? How many times the mom's age is of the daughter's age? What's the equation? You told me the difference. You figured this one out?
30 times 30 divided by 1.
Very good. Thank you
30.
so much. 30 divided by 1 equals 30. This is 30 times. Okay, so when the daughter is 1 year old, the mom is 30 years old. The difference is 29 years. Okay, but how many times the mom's age is the daughter's age? 30 divided by 1. That's 30 times. So the mom is 30 times as old as the daughter. But now I want to fast forward. So this is somewhere in the future. Okay, fast forward. And they're aging. This daughter and their mom, they're aging at the same speed, the same rate. So fast forward, this daughter is 30 years old. Okay, now we're switching. The daughter is 30 years old. Can anybody tell me how old the mom is at this moment?
90.
Not 90, Kevin.
60.
Felix, what did you say?
60.
60? Think again. The daughter is 30 now. The difference, the mom is
59. 59.
59. Thank you so much. The
It's
mom.
not supposed to be any time. It's supposed to be
Yeah,
plus
how did you
59.
figure that one out? Because
So-
the difference is always the same, right? So this 29 does not change. Your mom will always be that much older than you. It's not going to change over time. So in this many years, when the daughter is 30, the mom is 59. How did you figure that out? 30 plus 29 equals 59. Okay, so I'm writing down that equation under that number 59. Now let's figure out how many times the mom's age is of the daughter's age at this point. How many times? What do we do here? What's the equation? Alex, what's the equation?
It's like almost like the mom's age. It's like 2 times the daughter's age, but it's not
okay.
exactly.
Okay, all right. So we're looking at the ratio or how many times. It's 59 divided by 30. So we're not going to be able to figure out this one because it will have remainders. But I can tell you, let's make this 50 really close to 60. Can we do that? So let's just say 50 is it's almost like 60. It's almost like 60. So this whole thing is almost 2. So now you guys compare to 30. The ratio or how many times the two ages relate, that actually decrease over time. Now I want to give you an even more extreme example. Is when in the far, far future, when the daughter is 100 years old. Okay, anybody, can you tell me how old the mom would be at this time?
129.
Thank you so much.
The mom will be dead since no one can be older than 120.
Thank you so much, Alex. Yeah, let's just pretend the mom is still alive. Okay, thank you so much. Now, the difference is still 29, the same. Okay, guys, the same difference. However, how many times? Let's do how many times? 129 divided by 100. That's like close to 1. Okay? So we're going from 30 to 2 to 1. And so we're saying ratio actually decreases over time. And just think, okay, let's just pretend everyone lives forever. And in 10,000 years, this daughter would be what? Like 10,000 years old. And her mom would be 10,029 years old. And they would just get closer and closer to 1 over time. So the ratio decreases. Now, any questions? Any questions with these 3 rules? I want you guys to take notes, by the way. So I said you need to have your pen, your pencil, eraser, scratch paper, and your class notes. So if you have that piece of paper, one thing that's very important to keep you guys engaged is that you're writing. When you're writing down something, you're engaging your mind as well. So your hand, your eyes, your mind, they're all aligned. And that way you learn the best, right? Okay, so if we don't have any questions, I'm going to move on to the first example. Now, I want one student to just read the problem to us. Just read, okay? Who wants to read the problem? Irene, you want to read it? Yeah? Can you read example 1? Thank you so much.
Amy is 4 years old. Her sister Mia is 12 years old. How many years older will Mia be than Amy in 5 years' time? How many times Mia's age is Amy's age? How many times Mia's age will be Amy's age in 4 years?
Oh, thank you so much. Now, who wants to attempt The first question, how many years older will Mia be than Amy in 5 years' time? Alan, you want to do it?
Okay.
Yeah. What do you think?
So Mia will be 17 years old, and Amy will be 9 years old.
Mm-hmm.
So Mia
So-
will be 8 years longer than Amy.
Okay, so I'm writing down your methods. Alan's method is in 5 years, Amy is 4 plus 5 equals 9 years old. And Mia is 12 plus 5 equals 17 years old. Let's put old. So in 5 years' time, their difference, or how many years older will Mia be, is just 17 minus 9 equals 8 years.
Yeah.
Okay. Thank you so much, Alan. Anybody did it in a different way? Anybody did it in a different way? Which I'm talking about a easier way, okay? Anybody did it in an easier way? Tony, go ahead.
So we know that whenever the H's move, the difference is always the same. So we do 12 minus 4 equals 8.
Yes, rule number 1. Tony is applying rule number 1. What's that? Difference of 2 ages. Do not change. They stay the same. So we know now they are 4 and 12. So now it's 12 minus 4 is 8 years difference, right? So it'll be the same in 5 years. I mean, we can change this to 50, to however many. So I want you guys to form a habit. Is whenever you see this difference mentioned, in 5 years, 8 years ago, 9 years ago, 19 years ago, in 21 years, go ahead, cross this off. I don't want you to get confused. So it's basically asking you how many years older is basically, it's just how many years older is Mia than Amy. Okay, so that's basically the question, what the question is. 8 years, the same in 5 years. So this 5 years information, this is just to confuse you, okay? This is just to confuse you. Nothing else. It does not serve any purpose. Okay, second question. How many times Mia's age is Amy's age? How many times? Anyone? We already went over that. It's the usual people. Why it's always Tony and Kevin? Who else? Okay, and Flix. And okay. Nolong, you want to try? Jessie, you want to try? Okay. Who wants to try? Nolong, you want to try? Yeah, go ahead. Yep.
So when they say how many years will Amy be in 5 years' time?
No. We're in here. How many times Mia's age is Amy's age? How many times? What are we going to do?
So that means Amy's age is going to double.
No, this is not in 5 years. It's in present. Now, we know now Amy is 4. Mia is 12. How many times Mia's age is Amy's age? So this is basically the ratio question. Jessie?
So.
No? What should we do? What's the equation, Nolong? What is the equation? Is it 12 divided by 4? Is it? No, it's not. Tony, go ahead. Tony, how many times Mia's age is Amy's age? Did I do it right, Tony?
Kind of there, but you can also do the 4 times table. Like 4 times 3 equals 12.
So 3 times, right?
Yes.
That's now. This is now, because that's is, right? That's the presence. So how many times Mia's age is Amy's age? The answer is 3 times. Going to the third question. How many times Mia's age will be Amy's age in 4 years? Guys, this is ratio, okay? How many times? This is not difference. It's gonna change. You know it's gonna change. So what should we do? Alex, go ahead.
It's just like 17 divided by 9, but it's just like 16 divided by 8.
Oh, thank you so much, Alex. Yes, you did it. Yes, very good. So in 4 years, let's do this. We know it's going to change. So we're going to say in 4 years, okay, Amy is 4 plus 4 equals 8 years old. And Mia is 12 plus 4 equals 16 years old. So how many times is Mia's age will be for Amy's age? That's going to be 16. 16 divided by 8, that's 2 times. You guys see that? It's decreasing from 3 to 2. This is in 4 years. Okay, that is now. Now in 4 years. Very good. Moving on, we're moving on to second example. I want you guys to ask questions on example 1, if you have time to look at this question again. Okay, Nolong, do you have a question? Do you understand now? Yeah? Yeah, very good, very good. And don't worry if you don't get it completely now, because in the homework problems, we're going to have plenty of exercise over these concepts again. And we are going to go over all of your homework problem in next class, okay? So make sure you do the homework problems. Now, the second example, who wants to read this problem? We want someone to read it to us. Okay, let's find someone who has not talked at all. How about, is Kaylin still here? No, Kaylin is not here anymore. How about Chelsea? Yep, Chelsea. Can you read the problem to us?
I saw Kayla got kicked out.
She got kicked out? Oh no. Let me check the weight room. Is she there?
She's not.
No,
There's 12 people.
not.
There used to be 13.
Yeah, so we don't know what happened to her. Okay, let's see. Chelsea, go ahead.
The sum of the ages of Lucky and her mom is 53. Lucky's mom was 27 years older than Lucky. 8 years ago, how old are they now?
Chelsea, this is Lucy. Lucy, okay? So this is how we say this name, Lucy. This is a tricky question. Anybody has any clue who wants to share their thoughts on this one?
I have no idea what this means.
Yeah, but we can start with somewhere. We always start somewhere. This somewhere is 27 years older than Lucy. 8 years ago. Can we cross this out, guys? Do you all agree? We can cross it out because it doesn't change. So Lucy's mom will always be 27 years older than Lucy, no matter what time, no matter if it's present, past, or future, it's always going to be 27. So we start from there. Okay, so we cross it out. So we know the sum of the age of Lucy and her mom is 53. And one is 27 years older than the other. What we can do is we can build a model. Have you guys learned this method of build the model? So talking about this model, we're just using like blocks. Okay, I'm going to draw some blocks. So what we do is that we're going to do this. We're going to do Lucy's mom. We're going to give her a long bar. So this is a bar, right? Or a block or a brick, whatever you want to say. And then this is Lucy. Lucy's getting a smaller. Lucy gets something like this. Can we do that? Can we do that? So these two bars, they represent their ages. Okay, so mom is definitely getting a longer bar because you know mom is 27 years older. And Lucy is getting a smaller one because we know she's younger. And how much older? 27. So we're going to cut this off here. And we're going to give mom the same bar. So this is the same bar, okay? Just pretend this is exactly the same bar as this Lucy's bar. So what's the extra? What is the extra bar here? That's the 27 years, okay? What's the other piece of information that we know? We also know this whole thing together is 53 years.
Wait a second. I think I know how to do this now.
Yeah, see? When we draw
50
this out,
Can I explain this?
Yeah, Kevin, go ahead.
Okay, so since you have 27, you can minus 50. We can minus 27 from 53.
From 53 minus 27, that would be what? 26, right, guys?
Okay, and then
26
26 half
that's
is
26.
13.
Okay, so Kevin is saying, okay,
13 years old.
Kevin, I need to talk now. Okay, so Kevin is saying, so if we take that 27 years from that 53, if we take this guy away, okay, let's take this guy away. Now the left is just these two bars, the leftover, and we know that these two bars together, that's 26. And we also know, I told you guys, I made these bars exactly the same. What does that mean? Each of these bar is going to be 13. Okay, how did we figure that out? 26 divided by 2 is 13. Okay, each of these two bars, so this is years, and this is years, this is years. Okay, but the question is not asking you the size of the bars. The question is asking you how old are they now? Is asking you the total of this long bar and the total of this shorter bar. So their age would be what? So mom's age would be 13 is that shaded bar here plus 23. Her age is, what's this, guys? Quickly do the calculation.
40.
It's 40 years. Okay, mom is 40 years old. And Lucy, it's easy. Lucy's age, her age is just that one shaded bar. She's 13 years old. Okay, so how do we check? When we got our answers, very important for us to check. So there is two ways to check. First is that we check their difference. 40 minus 13. Is it 27? Guys, their difference. Is mom 27 years older than Lucy? It is. Very good. Thank you. So that's checked out. Now let's check their sum. 40 plus 15. Is that 53, guys? It is. So that one checks out too. So now we're confident to say mom is 40 and Lucy is 13. Woohoo, that's so hard. I'm so proud of you guys. We walked through this problem and we used that number one rule again. We're crossing out that 8 years ago. We're saying, their difference, age difference, always is going to be the same. So we don't care about 8 years ago or in 19 years, in 20 years. It's all going to be 27 years old. And then we drew a model. Once we drew the model, some students immediately said, oh, you know what? I know how to do it. Because this is the power of building a model. Is that it's going to illustrate, right? It's going to visualize the problem much, much better. Any questions, guys? I want you guys to take a look at this problem long and hard because this is the method you're going to use to do your homework, okay? We've got questions exactly like the same. I just changed some of the numbers. So you've got to know how to do this. But again, we're going to talk about those homework questions next class, okay? Any questions? No? We're good? Are you guys sure? Are you guys sure? Really? Are you guys sure? Yeah? Okay. Let's move on to the next example. Example 3. Evelyn, can you turn on your camera and also can you read the problem to us? Evelyn, can you read the problem? Thank you so much.
Jason is 5 years old and his dad is 43 years old. And how many years time will his father's age be 3 times Jason's?
Someone is in the... Okay, hold on a sec. I need to see weight room. How do I see the
This
weight?
looks like a hard question.
Someone is in the weight room, but he just disappeared. Did he disappear? No one is in the weight room now. That's a little weird.
What's a weight room?
I don't know.
It's basically a waiting room.
Yeah. Hold on. Let me stop share for a sec. I need to go check if everyone is... Yeah, I don't see this guy anymore. What's going on? Anyways, let's move on. Okay, so the third example, Jason is 5 years old and his dad is 33 years old. Thank you so much, Evelyn, for reading these questions to us. And now, oh, this one is really hard. Who wants to try to work with me? Who wants to try to work with me? This one is really, really hard. Okay, I'm not going to lie. So Kevin has a half raised hand. Okay, Alex and Tony. It's always the 3 of you. How about Flora? Flora, please. I want to work with you. Can we work together? Yeah. Flora said, yeah. Okay. And Luolong. Okay, so good. Okay, Flora, where do we start? Where do we start?
We start.
In how many years time, right? So basically what we're doing is now we know Jason. Now is the time point. Okay, time point is now. Jason is 5 and dad is 33, right? Okay, that's the piece of information that we know. But we're going to the future. And at this time, something is going to happen, is that dad's age is going to be 3 times Jason's age, okay? So Jason, okay, we're going to build a model here. Jason is like this much, and his dad is going to be like this much. 1, 2, and 3. Does that make sense, guys? Does that make sense? Very good. So the question is asking not about their age, but in how many years' time. So question wants to know how many years is going to pass between now and the future that Jason's dad is going to be 3 times as old as Jason. Okay, so one thing that we know what we can do is we can always figure out their difference because that's not going to change. What's their age difference? How much older is Jason's dad than Jason in years? Guys, come on. 33 minus 5. What is it?
28.
Very good. So difference is always going to be 28 years, okay? And that's not going to change. And we can safely write here the difference in the future is 28 years as well. So dad is always going to be, dad is 28 years older than Jason in the future, okay? So what does that mean in here? We know that we have this little bar for Jason. We have 3 little bars for daddy. Where do I put that 28 years here? Guys, look at this picture. I want everybody to stare at this model. 1 bar, 3 bars, 28 years older than Jason. Where do I shade out? Do I shade out this bar? Do I shade out this bar? Where do I shade out bars to represent the 28 years here? Tony?
Wait a second. 2 bars for Dad?
Thank you so much. Yes. Oh, I'm so proud of all of you. You're doing so well.
I
Okay.
had a feeling.
Yeah, because you
there's
know
no way
this time.
that
Okay.
there was
This?
no way that Jason can be 20 years old.
Okay, hold on. So in the future, we know that this little bar is going to be the same. So the extra bars Daddy have, that is 28 years. Now, anybody tell me what can we do with the 2 bars equal 28 years? Can we figure out each bar? We know that all of these bars.
Each bar is 14.
Thank you so much. So, because we know all of these bars are the same size.
Now 3 times 14 is 42.
2 bars equals 28. So each of these bars is just 28 divided by 2. That's 14 years.
And 3 bars is 42.
Okay, very, very good. You're working ahead. So we are writing down 14 on each of these bars. So we know that Daddy is 14 times 3. Guys, please, on your scratch paper, 14 times 3. What
42.
is it? 42? So in the future, when Daddy is 42 years old, Jason is 14 years. Okay, and we can check, right? We can check. How do we check? 43 divided by 14. Anyone? Is it 3? Is this thing 3? Jessie is nodding really hard. Yeah, it is 3. Okay, we're pretty sure. 43 divided by 14, that's 3. Very good. So checked out. However, we're not answering the question. The question is asking how many years time. It's not asking what's everybody's age. Okay, the question is not asking about everybody's age. It's asking in how many years time. What is this distance between now and future? That's the question. Anybody? How do we figure that out? Irene?
14 minus 5.
Oh, thank you so much. Yes, you guys are so good. I can't believe how good you are. So we're gonna do, what do we do here? We're gonna just say distance. Can we say distance? Distance between now and the future. 2 ways to figure it out. First way is using Jason's age. 14 minus 5, 9 years. Second way is to use Daddy's age. 42 minus 33. Guys, 42 minus 33, is that 9? Yes. So either way, you should get 9 years. Okay, I'm gonna frame this. This is our answer. 9 years, okay? Wow, we did so well. 9 years. Okay, guys, can you take a look at this problem and let me know if you have questions before we move on? I want to enlarge this so that we can see this. So how many steps? Let's just go back and think about this problem. How many steps did we do? Number 1, we draw this now and future. It's kind of like a timeline. Then we said, we have their ages now, and we can figure out their difference. And that difference is not going to change. So we write down 28 years for now and 28 years for future. And in the future, another piece of information is that Daddy is going to be 3 times as old as Jason. So then we built a model there, right? We had a 1 bar for Jason, and we copy down that bar 3 times to represent Daddy's age at that point. Then we are representing the 28 years with those shaded little bars, 2 bars. By doing that, we figure out, each of these bars is 14 years. And so we wrote down 14 years on each of these bars. And from there, we figured out, okay, in the future, Jason is 14, Daddy is 42. But the question we realize is not asking about the ages of them in the future, but rather asking about the distance between now and future. So then we went back, we're grabbing 2 ages of Jason, now and future, right? 14 minus 5, 9. And then we're checking, does, would the answer be the same if we use daddy's ages? 42 minus 33, 9. So, guys, hello? Good? Is that a good review? I feel like that's a really good review of this problem. And
that's the important one.
it's very important. And I'm just so proud of you guys. This is like how many steps? It's like 1, 2, 3, 4, like 4, 5 steps. That's a multiple step word problem. And you guys did it. Okay. So there will be something similar in the homework again. So you really need to look at this lecture notes, okay? And take notes, take notes, take notes, okay? All right, moving on to extra exercise. Anybody wants more? Are you guys tired? We have 5 more minutes, so we're definitely gonna tire you out, but no more word problems. Good news, okay? We're gonna give you guys something that's a little lighter to do. So what I am going to do is I'm going to give you this problem. And these problems are called number patterns, okay?
I think we did that in the 1B, I think.
In the 1B, yeah, it could be similar because, the first one is even and the second one, even odd numbers. Those 2 are easy, but the third and the fourth are going to be difficult.
I don't even understand the fourth one.
Yeah, so I want you guys to let's take a couple of minutes. Okay, the first and the second are very easy, but the third and the fourth will need you to think a little bit more, trying to figure out the pattern, trying to see what's the relation among those numbers. So we need, okay, so what would happen is that you would just look at this whole series of numbers and you're trying to figure out what's the relation among these numbers. And you're trying to figure out the missing numbers inside of the parentheses. Okay, that's what we want. Find out these missing guys. Wow, Lolong, you figured it out? You did? Wow, that's so good. Okay. Does everybody need a little bit more time? A little bit more time? I see a lot of people nodding and a lot of people shaking their heads. Okay, so let's give you 1 more minute. 1 more minute, okay? So, you know what? I'm going to start with the first 2 questions because it's just really, really easy and I don't feel like you guys need to talk about it.
It's
first,
just
let me.
uneven.
Yeah, it's just odd and even numbers. Thank you, guys. Yeah, so we're just going to do, so this series is, the first sequence is just the odd numbers. Let me write it down, okay? And the second series or sequence is just the even numbers. So we're going to do 5, 5, 7, 9, 11, and 13, right? Anybody have any different answers? I hope not, because this is just odd numbers, right? Now, what about the second one? 2,
Even numbers.
6, 8, 10, 12, 14, 16, And what's the next one, actually? The next one would be 17, right? The
That's
next
gonna
one
be
here,
18.
18. Thank you so much. And go on, and it just goes on, so on and so forth, right? Now, the third problem is the one that I want one of you to tell us. One of you. Nuolong, go ahead.
So how I think it at first when it's at 1, 2, 3, it's going by ones, but when it starts by fives, it's going by fours until 13.
Oh, going by fourth?
Yeah, so first it's going by 1, and then fourths, and then
What's this missing number here?
9.
That would be 9. Okay, what about this one?
So when it's at 13, we add an 8 that equals 21, and then if we add another 8, that'd be 26. I mean,
29. Okay. All right. Have you checked all of your, okay, so Nuolong, the problem with your approach is that you're saying this one is adding 1, this one is adding 2, and this one is adding 4, and then 9.
No, I never said that we were adding 2.
Okay.
Oh, wait. Actually, yeah. Hold on.
Yeah, hold on. Yeah, Tony. Tony, what about you?
It's the Fibonacci sequence. So
Oh, thank you so much for saying that name. Yeah, it's so cool, isn't it? You know what? Once I saw a guy, he has his car plate as a Fibonacci series. That's so cool. Okay, but anyways, Tony, tell us, what should we do here?
the answer is 8 and 34.
8 and 34. So good. And what is the rule or the pattern? How did you figure out 8 and 34?
So when the Fibonacci sequence is at the two numbers, like the right over there,
Sum of the two previous numbers,
and
right?
it
Okay, you need to keep yourself on mute, Lolong. Okay, that's not nice. All right, so sum of the two previous numbers. So let's check it out. 1 plus 2 equals 3, right? So two previous numbers, that's gonna give you 3. Now 2 plus 3, that's gonna give you 5. So these two numbers gonna give you 5. 3 plus 5, that's gonna give you 8. So on and so forth. 5 plus 8 is going to give you 13. Now, 13 and 8 is going to give you 21. So, 13 plus 21 is 34. So, we basically need these two. Thank you so much. Thank you so much, Tony. Now, the hardest one is the last one, okay?
I don't get it. I don't get the last
You don't get it.
one.
Okay, who got this number? Who got this one? Tony again. Let's see, who else? Alex. Okay, Alex, what's your answer? Let's see.
It's still the previous pattern, but it's like for the first one numbers.
Okay, Alex,
it's
just
like
Alex, tell me, what number did you get?
I think it is. I got 24.
24? Okay, who else? Who else? Do we have a different number? Okay. Tony, go ahead. What did you do?
25 is the answer.
Very good. 25 is the answer. Okay, I want to talk about this one because it's just so tricky. So D, you're like, what's going on? This 1, 1, 1, 1, right? But you notice 4 is what? 4 is just the sum of the 4 previous numbers, which happens to be 1, 1, 1, and 1. So let's try it out, shall we? So it's like sum of the 4 previous numbers. Let's try it out. Does this apply to everybody here? What about 7? The 4 previous number for 7 are these 4 guys. Okay, 4 plus 1 plus 1 plus 1. That works out for 7. How about 13? The 4 previous numbers for 13 is 7 plus 4 plus 1 plus 1. That works out too. So what should be this little number that's missing at the end? What should be that number? It would be whatever is missing. It's going to be 13 plus 7 plus 4 plus 1. And 13 plus 7 is 20. 4 plus 1 is 5. So this guy is 25. Whoa, so nice. We're done. We're all done. You guys are free to go. And I'm going to post the first homework in the website. And please ask your parents to print it out like today, okay? And so, because, okay, before you go, let me show you what the homework looks like so that you know what I'm talking about. So the homework, are you guys looking at the homework? Yeah. So the homework basically goes from Monday, Tuesday, Wednesday, Thursday, and Friday. So you're doing one problem a day, not too much, just one problem. Okay, but they're really, really hard. So I want you guys, I'm posting it today, so your parents should be able to print it out like tomorrow, and you will be able to do it on Monday. Okay, good deal. Yeah, I'll see you next Saturday. Bye-bye. Bye.
Bye.